Hi everyone, hope you're well. I just want to start by saying that a few years ago, Ozone asked me to develop some in-flight line length tuners, and they actually paid for the work. So I was very pleasantly surprised when they said that I could make a video about it and I could even sell these things on my website to their competitors. So I don't think it's every day that you see stuff like that. So big thumbs up to Ozone for making the paragliding community a better place. So what is the problem that we're trying to solve? We're trying to solve being able to adjust the line lengths in flight. Because every time they get a new prototype, they go out and fly it, see what's good and bad about it, and often they will adjust the line lengths. Let's say the tips are too fast or the whole profile is too aggressive. The way they do this is they go out, they fly, they do some maneuvers, they top land if they're lucky, they put some loops in the lines around the melons or take some out and then go and fly again. So it'd be much better to be in flight, do some maneuver, do an adjustment, and then do another maneuver straight away, and you get the immediate feedback. So since that's what we're trying to achieve, let's look at some requirements that we got from Russ. So they would like to adjust the length up to a total of 25 mil. It would need to have like each increment to be about 3 or 5 mil. Quick and simple to change between wings. Be rated for 8G, so we're pretty much trying to get the line to break rather than whatever we put on it. Oh, and a big thing from my side is that to make sure that the mechanism is fail-safe. So if anything is to happen, it doesn't damage the line, and if for whatever reason my mechanism breaks, the line goes back to where it was. So I looked at a number of different concepts and split them into two areas. External, that work directly on the line, and internal concepts that actually work as a connection between the riser and the line. For internal, I looked at a ratchet strap. You see these in trucks. That's something that the more you action the lever up and down, the more it rotates. And also one of the very initial concepts was kind of like a guitar tuner. It's basically a worm in gear, which makes it quite nice because you have lots of adjustment, and when you turn the worm, it turns the gear, but if the gear tries to turn, it doesn't turn the worm. For external concepts, I was thinking of something similar, where you will rotating the line around a drum, and the diameter of the drum will allow us to choose how much adjustment we have. And then with these tabs, we end up being able to lock it. Also, we could have a spiral, which basically we are deflecting the line. So if the line is not straight, if it's deflected, the distance between the endpoints ends up being smaller. And this same concept with the zigzag pins, it's just an offset track that ends up deflecting the line. Then I made, kind of tried to rank them against a few of our criteria. So how fail-safe it is, how easy it is to 3D package, because sometimes the lines are very close together, so if they're very bulky. How ergonomic it is to use, because we have to be able to use it. How much development time it will take, how much cost, number of parts, and then so with each of the concepts I attributed a score and then try to see which ones are worth taking further, because if we can cut down already a lot of concepts to start with, we have a lot less work to do in the future. So then based on that, we had a couple clear winners here, and we went on to design a little bit more and start 3D printing. So the first one I've done was this winding lever, but it had a few issues. First of all is how much you adjust the line depends on the diameter of this drum. And the other issue is there's always be some stress concentrations around the sharp bends. In terms of 3D packaging, it wouldn't be great to have all these arms everywhere. A pretty fatal flaw for this is you have to thread the line through the little hole. Which means you'd have to disassemble it, and then the hole would have to be big enough for a loop cross section, which is bigger than just the line itself. So then the other winning models were these spirals. Have a channel in the middle for the line to go through, or you can wind it around one of the spirals. And these seem to work okay. It's a single part, which is obviously really good. In terms of packaging, is very much the form factor of the line. So then I thought this thing is a pretty good candidate to explore a bit further. I thought I'd lose the hole so that you don't need to thread it. So this one you should be able to put up to the line and use directly, but then the problem is, how do you keep it from falling off if you don't have any adjustment, any loops in? And then I came up with a couple of things for that. You could have a little Velcro on the top, so you'd feed the line through and then you'd close the Velcro, and that should be easy enough to work in flight. And the other way was to have some kind of a sleeve. So with this one as an example, this on this one you'd have to thread it through, and then as you're flying, the line would be inside. You could pull the sleeve down, do your turn, and then pull the sleeve back up. This is because Russ told me that Velcro is the absolute worst thing for unsheathed lines. The hooks grab onto the Kevlar and rip it to shreds, so we couldn't really use this in this function. From this to this, we also went for a different in outer diameter for ergonomics, so we can actually use it and for the piece to be stronger. And then did a lot of work on the actual final shape. It was quite promising to actually test these on the line, because it's a very smooth curve, it's a very smooth spiral that the line goes over. It doesn't put a lot of strain on the part, and it also doesn't induce a lot of stress on the line. So on all of them, when load testing these, I had the line break away from this. So all of the lines broke very close to what their nominal braking strength is. Our parts, some of them cracked, some of them didn't, but none of them actually broke before the line. And a couple of other things to bear in mind was manufacturability. I tried on a few of them to make it a flat bottom so it would be easier to 3D print on an FDM printer. That didn't work super well. I also tried to make it in two halves, so I would one half there, one other there. Then you would put them together. That also didn't work super well. How much do we want to adjust it by? So I made versions for 2.5 mil, 5 mil and 10 mil per turn. So again, that was going to have slightly different geometries. And you also have to account for the thickness of the line. So a brake line, for instance, sheathed at the outer diameter is about 2 mil. An unsheathed Kevlar maybe on the Cs that don't take a lot of load might only be 1 millimeter. So on these I tried different coating methods with epoxy, kind of giving it an exoskeleton, making it stronger and making the line be a bit more slick. You can see there that sometimes it worked a bit better than others. But for instance, on this, you can see the layer lines, and that would catch the line. And it's not the strongest thing in the world either. So we definitely wanted to make sure we're creating something that is fail-safe and smooth. It doesn't damage the line, it doesn't break easy. So to take the project to the next step, we definitely need to address the manufacturing process and the material used. And for that, I used PCBWay. And I'm super proud to announce that this channel now has the first ever proper video sponsored by PCBWay. Well, PCBWay does PCBs, obviously, but they also do SMT assembly. So after you do the PCBs, actually putting all the components in it and shipping it to your door already fully assembled. So this is actually how I do PCB Mini. But other than all of the PCB stuff, they also do CNC machining, industrial 3D printing, but also stuff like sheet metal fabrication and injection molding. So it's really like a good solution if you want to try things that, the machine would be super expensive for you to buy. So for 3D printing, you can try stuff like ABS, PLA, PETG, TPU that you could do probably at home in a small form factor 3D printer. But there's also other stuff that is harder, like resin or nylon. As well as aluminium, stainless steel, titanium. These are probably sintered materials, but again are super interesting to if you have something that is small volume that you can just try a stainless steel part, for instance. Obviously, these are made from powders, but you could also have CNC machining of a whole load of materials, sheet metal, of a load of materials, and even like injection molding. But obviously, this is for when you get really serious with your projects. So all I did was go to 3D printing. I've added my CAD files. I wanted nylon and I chose the HP A12. I think I could go even stronger with the glass fiber reinforced one. But yeah, just follow the process. It's really easy. I've asked them to give us a coupon code, so all of the details are in the description. But thanks PCBWay for sponsoring this episode. And now let's see how our parts turned out. So the PCBWay parts have arrived. And I've got 3 batches, the 1.5, 1.4 and 2. So this is nylon. This is really, really strong. Even with these deep cuts, it's still super strong. So these to the naked eye look identical really. That's why on the bottom of them I wrote what diameter wire they are for. And I'm really happy how they turned out. Not sure if you can see there, but I've engraved the millimeters adjustment. I did cut a few before and I also broke it just to see how much force it takes to break. And it's a considerable amount of force and it's in bending like this. So trying to bend it like this, which is not how it's going to be loaded. So I'm super, super confident that these can be dropped and stepped on and for sure they won't break. And with the line, just with the line pulling them apart, it's never going to break. I also ordered a whole load of these little clips and I've made some myself as well. This one I've printed here at PLA. These 2 are nylon from PCBWay. So these should go like this. So you can open it and now the line can go through there. And then you can close it. Now it's locked onto the line. And obviously same thing on this side. So the way I do it is just to unlock the top. Now it's only captive on the bottom. So I can put a turn in or more. If I want to do more, I could do 2. So now that's 10 mil shorter. And I can lock it back on the top. And that's not going anywhere. Ozone has had these for a few years now, but I know that a few other wing manufacturers have tried them out as well, which is pretty cool. If you know anyone that is interested, I'll leave a link in the description that they can get in touch with us and we should be able to get them some. So that's it for the project. It's taken a couple of months to do, but about 4 years to do this video, so sorry about that. There's a few like that in the can that will come in the future. But again, huge thanks to PCBWay for being our first ever sponsor. Amazing. Big thanks to Ozone for letting me come up with this in the first place and allowing me to share it with the world. And last but not least, thank you so much to everyone on Patreon and YouTube memberships which have been supporting us for a long time, especially through long stints like this without putting videos out. Thank you so much to everyone. Don't forget to subscribe if you haven't already, and I'll see you in the next one. Bye bye.